team number 1, and our team consists of 6 passionate students studying at Nazarbayev Intellectual School in Nur-Sultan, Kazakhstan, and are currently passing to 12th grade. As it can be seen, our team addresses the NGN 2120 Goal 5, which means that we want to provide healthcare access for all. Under the auspices of this goal, we are pleased to present to you our joint project called RUV, which could possibly prevent infection of visually impaired people with COVID-19. We want the judges to act as investors and social impact entrepreneurs.
According to World Health Organization, currently there are 39 millions of blind people and 246 millions of visually impaired people. And both groups can read braille, which could be found in elevators, in stairways, and so on. And the question is, how can we help visually impaired people feel safe using braille to navigate in public spaces, especially hospitals, without being at risk of spreading or contracting COVID-19. Visually impaired people navigate the world using sound, smell, and most importantly, touch. Most elevators are made using metal, and according to researchers, COVID-19 can survive on metal or plastic surfaces from 2 to 5 days, leaving visually impaired people at a high risk of catching the virus. And as the issue has been posed, let's consider the existing solutions. For instance, there is a smart elevators by Ashra Systems, which costs $4,000 per elevator, which is extremely costly. So the next one is Push Safe. It uses adhesive strips with hygienic button pushers. And though this way it hinders reading braille for visually impaired people. So in the end, these solutions are either very expensive to manufacture or don't even consider the accessibility or safety for visually impaired people. So our customers are to be hospitals and clinics, malls and public transportation, subways, airports, coffee shops, retail kiosks, and public buildings.
So that's why we have prepared a solution that considers both economic and accessibility issues. UV fixture can be installed in elevators, and it can kill the germs during the time span while elevator is empty. UV light has been used extensively for more than 40 years to fight infections, including COVID-19 related viruses like SARS-CoV-1 or MERS-CoV. Moreover, universal design is for everyone because simply UV light destroys a virus that lives on button, which protects everyone else. So the mockup can be seen on the slide, and our philosophy consists from 3 main parts. First one is inclusivity. That is, our product considers visually impaired people and their specificity. Second is autonomy, which means that our system works without any human control, automatically independent. And third one is accessibility. Users shouldn't apply any extra effort to use our product, meaning that it makes safe the usage of buttons for visually impaired people. Our elevator pitch is following. Button panel accounts for a major portion of contacts, and this contributes to the spread of COVID-19. And our product RUV protects visually impaired people as it disinfects the panel using ultraviolet light. The solution is cheap as it costs only $50. So we're elevating safety while elevator is empty.
So, goal is, we want you to give us grant funding of $10,000 for the following purposes. Firstly, to conduct research in order to determine the best UV light emitter, considering its optimal wavelengths. Second is develop the product and order materials for the first 50 testing prototypes implemented in elevator. Thirdly, some organizational measures and issues such as registering our company, paying entry taxes, hiring technical personnel, and hiring a lawyer. And fourthly, focus advertising and marketing through B2B and B2C strategies through partnership for awareness. Wait, where's our teammate?
Okay. He's probably missing, so I would continue. Who can we partner with? There are a lot of NGOs that could support our idea. For instance, American Council for the Blind, American Foundation for the Blind, and etc. And as for our local region, we can partner with National Center for Biotechnology and research groups in Nazarbayev University to test on different samples of COVID-19 for determining the best emitter and develop the product further. And second, incubators of SIA Kazakhstan and the first president's funding in order to expand our company. Third is housing cooperatives such as BI Group and city administrations of Almaty, of Nur Sultan, and Fab Labs within Astana Hub in order to supply workshops with tools. And also we can work with US Embassy, Chevron, in order to expand within CIS countries. So we have prepared some empirical validation. Let us watch.
A person infected with coronavirus comes to a panel in elevator. Then, when he leaves the elevator, PIR motion sensor detects that no one is in the lift, and so activates the UV light emitter to disinfect. UV works for several seconds, so when another person enters the elevator, UV light turns off. Therefore, this blind person can safely use a disinfected panel. And as you can see, UV strips are attached to the moving element that slides outside when activated and inside when deactivated, preventing the vandalism.
So we are Team 1 presenting the product RUV, which can help visually impaired people safely use elevators and other public navigations. And so we call you to give us a grant funding in the amount of $10,000 for that realization. With this, we can support visually impaired people, especially during this terrible period. Thank you. Any questions?
So this is the time judges ask the questions, if you have any.
I have a question for the team. Thank you very much for your presentation. This is Samina. I think on your pitch where you had A, B, C, D, E, you're missing C. So I think A, yes. So purpose, advertising, and marketing. So
yes, that's just the template we used. And the C is just in the UI. And we only consider the fourth point. But for the aesthetics, we used that like template.
Yeah, it doesn't convey any information. It's just a template for presentation, something like that.
Okay, thank you very much.
Hi, this is Madan here. Can you guys hear me?
Yes, we can hear you.
Yes. Okay, excellent. So when you consider the practical application of such a device, most of the elevators already exists in the world today. And the question becomes like, okay, how do you actually plug in your attachment and how do you actually like make it work? So it really means like retrofitting all of the existing elevators is almost next to impossible because they basically live for like almost like decades, right? So have you considered, how do you think it's going to work? Like where does the power come from? Have you considered some sort of?
May I start, please? As we said before, we're going to collaborate with the local companies. We're going to start with the CIA countries, and we're going to collaborate with the local building companies, which, if we will be lucky, they will allow us to introduce our solution, and then they can implement this solution in their buildings, in their elevators. Like we said, BI Group company, there is also Basis A building company in Kazakhstan, and step by step,
I can continue. So recently we found that actually some startups and some projects regarding like implementing some electronics into elevators are very like spread it, at least in Kazakhstan. So for example, we have a company called Lift Media. Well, Lift is in Russian elevator, right? So it's this company managed to spread its own devices. Devices are basically monitors with ads inside elevators, and they like work as a safety structures in case of fire, in case of vandalism, and so on. So they managed to implement those monitors around whole city of Astana and whole city of Almaty. And now they're expanding to other countries, and now they're moving to Kazan, which is in Tatarstan, which is in Russia, and they're like, we just want to, in this sense, we just want to adapt their experience into our product, which is also located in elevators. So
also, even our prototype is not big. It's very compact, very mobile. It has such sizes, like it's not very big, and it has no any complex elements like monitors or screens. So it won't be a problem to power it and to place it inside the elevator.
Yes.
And finally, I think the question was more technical, right? Like, how are you going to implement this structure into different types of elevators? How are you going to consider those differences in structure, in voltage, and so on? So our proposed solution is, well, we need to hire like people which like will do it technically. I mean, like welders, hookers, and so on. And all other parts regarding electronics will be like done with the help of again Nazarbayev University. There is a engineering and there is a school of engineering and digital sciences, and within the school there is a lab of power electronics. So we think that we will collaborate with this lab in particular, and then there we will like think about technical issues. What if there will be too much voltage? What is optimal voltage for structure, and so on. But for now, we designed prototype based on Arduino, but most of prototypes, again, I'm referring to Lift Media, which is a huge company here dealing with lifts. They're making their prototypes on Raspberry Pi, so it's pretty manageable.